In this video, we're going to talk about finding the mean and variance of transformed or combined random variables. So what that is we have y equals ax plus b, where x is our random variable and a and b are the transformations. So for our expected value, the expected value of ax plus b is equal to a times our original expected value plus b. For the variance, we have the variance of ax equals a squared plus, or a squared times variance x, and the variance of x plus b is just the variance. So what that means is if we have the transformation ax plus b, no matter what, our variance will be ax squared plus a squared times variance x. So for this first example, we are given that our expected value is 4.01 and our variance is 1.1. For this first transformation, we want to find the new expected value. So what that is we're going to multiply 2.5 by our expected value and add 1. So 2.5 times 4.01 plus 1 is 11.025. For our variance, that value we're adding 4 won't actually affect it. It will be a squared times our original variance, so 0.2 squared times 1.1. Our new variance is 0.044. For this new example, we are given a binomial distribution. So remember, our expected value for binomial is n times p. So 7 times 0.2. For our variance, it is n times p times 1 minus p. So our variance for that binomial distribution is 1.12. So finding our new expected value after the transformation, we'll have 1.4 times 3 plus 2. That new expected value is 6.2. And for our variance, 1.2 isn't going to affect it, so it will be 0.9 squared times 1.12. Our new variance is 0.9072. So for our second example, we are given a Poisson distribution. Remember that our expected value and our variance is our parameter, which is 4.2. So for our expected value transformation, it'll be negative 1.7 times 4.2 plus 5.1, which is negative 2.04. For our variance, it'll be 0.9 squared times 4.2. So our new variance will be 3.402. So for a combination, if we have z equals ax plus by, our expected value is ax plus by, which is a times the expected value of a times the expected value of x plus b times the expected value of y. The plus or minus is all just dependent on if the question is specifically saying you are adding or subtracting. For your variance, it is very similar. You do take the square. But if you notice, it doesn't matter if you're adding or subtracting these combinations, you will always be adding when you break it apart. So it is a squared times variance x plus b squared variance y. And x and y must be independent of each other. So for this first one, the first thing we need to do is find our expected and variance for our different situations. So for the binomial, we have 1.6 and 1.28. For our Poisson, remember, it is just the same. So it is 2.3. And then for our normal distribution, our mean is 11.7. And our variance is 1.7 squared. So for our first one, we have 3m minus 2u. So our expected value of m is 1.6, so 3 times 1.6. U is 11.7, so minus 2 times 11.7. That new expected value is negative 18.6. So for our variance, now for this one, we have 2.3 plus 3 squared times 1.28 plus 0.7 squared times 1.7 squared. Now the reason why the 1.7 is squared is because in our normal distribution information, it specifically says 1.7 squared. That whole thing represents the variance. So calculating that, it is actually 15, not 17. And the example in the notes, it actually has a poison of 4.2, and that is what that calculation came from. Whereas this says 2.3 for our poison distribution. So that number is off just a little bit.